Hello, myself Bilawat Sravant Naik. Today I am saying about my project was hand recognition. We use in these libraries and we using to test the accuracy. We use these libraries and we included the for X for pixel values and Y for digitals, and we use the one hot encoding labels to convert to one hot vectors, and we use to split the train and test sets. We use for training 80% and test sets for 20%, and we use in the network initialization a simple neural network with no hidden layers. And here we clearly say weights is equals to W and bias is equals to P to initialize it randomly, and softmax activation function to convert the network's outputs into probabilities of each digit classes, and we use in the loss functions used to cross entropy losses suitable for classification problems. And here you will clearly see training groups use the mini batch gradient descents and tracks loss every 10 approaches, and we can see our predictions and evaluations after training. Predictions predicts the labels of on the test sets and computes accuracy using sklearner, and final test with the external data loads and another test files mini test, and we are using this data and predicts the and evaluates the accuracy on it. And here we can say the softmax for multi-classes classification and cross entropy losses mini batch gradient descents, and here we can see the output, and here is the result, and we can see clearly training accuracy is 91.10%, and here we see the load the new test data and the predict of the test set. Here we using the y for, and we can clearly see that this accuracy, and this is we use for plotting that's the final test accuracy to upload the file is 91.83%.
And I will explain the decision tree algorithm. So first we have the library implementation and we import the decision tree classifier function of the sklearn library. Then we train our model on decision tree classifier, and we get a quite high accuracy of 86.85. Then we compute the entropy of the labels. Then we have defined a dictionary which is in numbers, which keeps in track of the numbers or values in the MNIST database. Then we have the compute entropy threshold function. Basically, what it does is that it along a certain index, along a certain column with the index, it computes the best possible information gain. For efficiency, we have also added that if the feature is not in computed values, it will append the feature's value in the computed values list. This does that. It does not recalculate values it has already calculated. After that, we inform the best split and return the position of the index which is the best split in the data range. After that, we have a class of decision tree node and the decision tree itself. So we have certain functions in it: fit, train, predict, sample, and predict. Then we import the confusion matrix to visualize our code and our results. So we have X test, Y test, then we perform testing on the data set, and we have to keep the nodes at least 2 to the power 4 for classification. And then we also have predict only for the first 100 classes due to computational costs. And as you can see, we get quite low accuracy of 20%. Thank you.
Hello, this is Hema. I'm gonna explain how I implemented Bayesian classifier for our project handwritten digit recognizer. So we start by uploading data, which consists of features representing pixel values and labels, which are digits. We split this data into training and test set using 80 is to 20 ratio to train and evaluate our model effectively. And the next step is prior probabilities. We calculate a prior probability for each digit. This means we are finding frequency for each digit appears in our training data. And for the third thing is likelihood. The mean and variance of each pixel of each digit class. This helps us model how each pixel behaves across different digits, assuming a Gaussian distribution. We also add some epsilon to the variance just to avoid the division by zero. And the next step is a Gaussian log probability. A function for the Gaussian log probability is working in log space helps avoid underflow when multiplying small probabilities across many features. And for each test image, we calculate log posterior probability for each digit class using Bayes theorem. We then choose the class with the highest probability as our prediction. And the final thing is evaluation. We test our model on the test data. The classifier goes through each test image, predicts the digit, and counts how many it gets correct. In the end, we calculate and print out the overall accuracy. Thank you.
Hi, myself Prince. I'm going to explain my part. This code implements a convolutional neural network (CNN) using transfer flow and keras to classify handwritten digits from the MNIST dataset. The model is built with multiple convolutional and max pooling layers, followed by filtering and dense layers with ReLU and softmax activation. It is compiled using the Adam optimizer and catalogical cross entropy loss. The model is trained on the training set and evaluated on the test set. Finally, the accuracy and the loss are plotted to visualize the model's performance.
Hello everyone, this code demonstrates a custom implementation of k-nearest neighbor algorithm from scratch without relying on machine learning libraries like scikit-learning. It begins by loading and flattening training data, images and labels, and test data from NumPy files. The core of the code defines a KNN classifier class, which includes method to fit the model by storing training data, predicts label for new sample by computing including distance and selecting the majority label among the k nearest neighbor, and evaluate accuracy by comparing prediction to accurate labels. The trained model with k equals to 3 is saved using pickle and later reloaded to ensure persistence. Finally, the model performance is tested, achieving accuracy of 45% and sample prediction are displayed alongside actual labels to illustrate its behavior. The implementation highlights the fundamental mechanism of KNN. Thank you.